Okay, in this video we're going to learn about momentum and impulse. So momentum is defined by the following formula. P equals mv. The mass of the object multiplied by its velocity. Now there's another term called the impulse. Often the symbol that we use for impulse is J. Sorry that it's not I. The impulse is just equal to the change in momentum. Now impulse is very important because it is the relationship between momentum and force, and this has a profound implication. So let's consider for a minute, if we were to look at what is our impulse here, it is equal to our change in momentum, which is equal to the mass of the object times the change in velocity of the object. Now that is assuming that the mass of the object is not changing with time. But if we have a look at this, this is equal to the mass multiplied by the integral of a over time. Now, as the mass is constant, I can actually just pull that inside the integral in this case, and so that means it's equal to the force integrated over the time. So what this tells us is that to find the change in momentum, how an object's momentum changes, all you have to do is add up the force applied to that object over every set in time. Now let's consider that and take Newton's laws into account. So Newton's first law states that an object will continue moving at constant velocity unless acted upon by a force. What that tells us is then that the momentum of an object is constant unless it interacts with some sort of other object. Now Newton's third law tells us that whenever objects interact, they apply equal and opposite forces to each other. This must mean that they are also applying equal and opposite impulses to each other, and so they must exchange equal amounts of momentum. So, taking Newton's first and third laws into account tells us that momentum is a conserved property in all cases. Momentum can be transferred between objects, but it cannot be created or destroyed.